Section 7.4. Our objective today is I can use the angle-angle similarity postulate and use similar triangles to deduce information about sides or angles. Okay. The angle-angle similarity postulate gives us a way to show that two triangles are similar without having to prove everything about similarity. And so if you can show that two angles of one triangle are congruent to two angles of another triangle, then you can say that the triangles are similar. Okay, so for instance, example, let's say I have this triangle and this triangle, and I want to know if they're similar. And I know this angle is 62 degrees, this one is 60, this one is 54, this one is 60. So we find the third angle of each one. This one is 58, and this one is 66. And no two angles of one are congruent to two angles of another, so these are not similar. So we can say definitely that they're not similar. If I have this triangle and this triangle, and I know this is 50, this is 60, this is 50, this is 70, and I can deduce that this one is 70, then this one has to be 60. So I have two angles of one congruent to two angles of another, so therefore I can say these are similar triangles. Okay. In this example, the only thing I can determine is that I have two right angles, but I can't determine anything about the other angles. So in this one I would have to say no conclusion, because I don't have enough information to determine if they're not similar or if they're similar. Okay. Then we use the idea of similar triangles in order to solve for unknown values. So for example, let's say I have this picture where this is triangle A, B, C, and I have segment RS, and I know RS is parallel to BC, and I know this is 8, this is 4, this is 10, this is Y, this is X, and this is 15. Well, I can use similarity and proportions to find the unknown values. So first of all, we know the triangles are similar because since RS is parallel to BC, we know this angle must be congruent to this angle. And triangle ARS and triangle ABC share angle A. So I have two angles of one congruent to two angles of another. And if you notice, again, we have two triangles. We have triangle ARS, which has lengths 8, 10, and X. And then we have the bigger triangle ABC. So this one has lengths of 10 plus Y, and this side is 12, and this side is 15. Okay? And so the first thing we want to do is determine a scale factor. Because these are similar triangles, we know it's going to have a scale factor. So this side corresponds to this side. So if I do small to large, then my scale factor is going to be 8 to 12, or 2 to 3. So that's my scale factor. And then if I want to say no X, I would set up the proportion 2 is to 3 as X is to 15, because RS corresponds to BC. Okay? and then I would just do means and extremes. So I would get 30 is equal to 3x, so x equals 10. Okay? Then if I wanted to know y, again, I would use my scale factor, and AS corresponds to AC. So I would set up my ratio of 10 to 10 plus y. Okay? Then doing means and extremes, I would get 3 times 10 equals 2 times 10 plus y. And I would get 30 equals 20 plus 2y. Subtract 20 from both sides, I get 10 equals 2y. And so I get y equals 5. Alright? So let's look at another example. So let's say I have this picture, and I have this segment, and I know this angle is congruent to this angle. This is 4, this is 2, this is x, this is y, this is 6, this is 3. So again, notice I have two separate triangles. I have a small one where this is 4, this is x, this is y. And then I have a bigger triangle where this whole side is 4 plus 2, so this is 6, and this whole side is y plus 3. Okay? So again, they are similar because they share this angle. So I have two angles of one congruent to two angles of another, so they are similar. So then I can set up my scale factor. Again, I'm going to do small to large. So I get 4 to 6 or 2 to 3. So that's my scale factor. Now let's say I want to find x. So 2 is to 3 as x is to 6. So I get 12 equals 3x, so x equals 4. Then if I want to find y, again I use my scale factor, and then this corresponds to this, so small to large. So I have y over y plus 3. Do means and extremes. So I get 2 times y plus 3 equals 3y. And then it's just a matter of solving. So I get 2y plus 6 equals 3y. Subtract 2y from both sides to get y equals 6. Okay? Next example. Okay, so I have these two triangles. This is 5, this is x, this is 4, this is 8, this is 6, this is y. So first I have to determine, is this triangle similar to this triangle? And they are, because we can say this angle is congruent to that one by vertical angles. Then I need to line up corresponding sides. So this side corresponds to this side. So if I again do small to large, I have 4 to 8 or 1/2. Okay, so my scale factor is 1/2. So then if I want to find x, it would be x over 6. So 6 equals 2x, or x equals 3. And if I want to do y, it's going to be 5 over y, or y equals 10. Okay, now let's do a proof. Given that angle 1 is congruent to angle 2, prove that the length of BD times the length of CA is equal to the length of BC times the length of DE. Okay, so basically, remember that we could rewrite this. So if BD is here, CA would have to have been there. Okay, and if BC and DE. Okay, and remember those can change places. These two can change places, but that's basically where it came from. And we have this picture. Okay, so this is A, this is E, this is B, this is D, this is C. This is angle 1 and angle 2. Actually, let's go ahead and change these, because I think that's going to work out better. We could do it later, but let's just do it now. Okay? All right, so first of all, we need to prove that the triangles are similar. So we have angle 1 is congruent to angle 2. That's given. And number 2, angle B is congruent to angle B by reflexive. Okay. Then we can say triangle BDE is similar to triangle BCA, and that's by the angle-angle similarity postulate. Remember, the squiggly line means similarity. Then we can say that BD is to BC as DE is to CA, because corresponding sides of similar triangles are in proportion. Okay, and now using means and extremes, doing the cross multiplying, we get the length of BD times the length of CA has to equal the length of BC times the length of DE. And you can either say means and extremes property, or you can just say a property of inequality.